Hi friends, I am Yashwardhan and today I am going to see how you can design a monopole antenna using a HFSS software. To do this, first of all, you need to open your HFSS software. Now, if you has not installed the software, I have already done a video on how to install this software easily. I will link it down in the description, and also I will keep it in the I button. You can watch that video on this. You can watch that video first and then you can see this video. Now, upon opening the HFSS in HFSS software, an interface like this will come. In the left hand corner, you see there is a project 1. You need to right click on it, click save as, and then by default it will show the folder where you have already stored where you have stored the program files. But if you want, you can change it. Like I want to store this on my desktop, and I will say this has my half wave. Sorry, this is monopole antenna, and I will say save. It will save that file. Then we need to create a HFSS model. To do that, what we do, we need to click on this button, and then a HFSS model is created. Then we need to go to HFSS, go to solution type and select the driven type. If it is not selected, click OK. Then go to modular, go to units and select millimeters as the units. Next, again go to HFSS, go to design properties, and here we design all the different variables that we are going to use in our design. So to do this, first of all, I need to include speed of light, which is 3 knot, and as it is speed, I will just say S and then I will select speed, and units are meter per second, and we know the speed of light is 3 into 10 power 8, so we need to write 3 followed by 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 8 zeros. Next, that is 3 into C naught. Next, I need to now mention my operating frequency F naught, and as it is frequency, we need to keep it as frequency unit type, and units are gigahertz, and I am taking it as 1 gigahertz and click OK. Now I need to add lambda which is length, so I will just say select length, units are millimeter, whose formula is nothing but C naught divided by R F naught, and click OK. Next, we need to add radius of monopole, which I need to write radi underscore monopole, and as this is also length, you need to select length units. And what is the value of this radius of monopole, if you may ask? It is nothing but lambda divided by 4, which whole divided by 60. Click OK. Next, click on that. Now we need to define the gap between the ground and the monopole, which is named as gap. What is it? It is nothing but radius underscore monopole into 2. Click OK. Next, I need to give the height of my monopole, which I left as monopole length, and this units are length, unit type, units are length. And what is the height of this monopole? Is nothing but what is height of this monopole that you are designing? Like, what is this height? Is nothing but lambda divided by 4 minus whatever is the gap, and I will say OK. Then I need to define the radius of the radiation boundary, which I say radius underscore co. Unit you need to select as length, and what is it? It's nothing but radi underscore monopole plus your lambda divided by 4, and click OK. Then I need to define its side, which is nothing but A underscore co, and its units are again length, and this is given as gap plus monopole plus brackets of lambda divided by 4 plus another lambda divided by 4, and I click OK. Now once all the units have been, all the variables have been created, you can click OK. Now the first step is to create a monopole. To do this, you need to select this draw cylinder tool and you need to draw a cylinder like this. Now at the left hand side, you can observe that there in solids this is open. You need to right click on this, left click on this cylinder and change its name to monopole. And we need to assign the material, which is nothing but PEC, which is perfect electrolytic conductor, and I will say OK. Okay. Similarly, next you can even change the color of your monopole. By default, I will leave it as it is, and you can see how much transparent you want it, and you say click OK. Now we assign its dimension. So its dimension is nothing but 0 millimeter, comma 0 millimeter, comma what is a gap, and its radius is nothing but radi underscore monopole, and what is its sign is nothing but monopole. That's it, and I'll click OK, and it is created. But you may not see. To see it, you need to click on this, which will fit all the contents in your view. Now next thing is to create a infinite ground. To do this, you need to select draw circle tool and draw one circle. Now right click on the circle and name the circle as your infinite ground. Name it as infinite ground, and let me change its color to orange, and I say OK, and then OK. Now let us see what we need to assign its variable, which is nothing but 0 millimeter, comma 0 millimeter, comma another 0 millimeter, and what it is nothing but radi underscore go, and I will click OK, and then it will be created like this. Now we need to assign a radiation to this. So to do this, you need to select the circle, go here, right click on it and go to assign boundaries and click perfect electric field. As this is an infinite ground plane, you need to select this, right click and click OK. Now to verify whether the whether the perfect electric field is applied or not, you need to go to this HFSS, go to boundaries and click on perfect electric field. You will see its electric field direction. Now it's OK. Then you right click on it. Now next we need to create the pole. To do this, select the draw rectangular toolbar and make the axis as YZ axis. Now draw one small rectangle. Now go to this rectangle and name this rectangle as your source, and leave the color as it is, or you can change the color of your initials and click OK, and increase the transparency to 0.2 and click OK, and this will be selected. Now to assign its height value, which is nothing but 0 millimeter, comma minus radi underscore monopole, comma 0 millimeter, and it is in along x direction. What is it will be y size, you can ask. It is nothing but radi underscore monopole into 2, and this size is nothing but my gap, and I click OK. You can observe that it is being created. Now to zoom in, you can use this option and zoom in to your index. Now you need to assign the excitation. To do this, click on this source and right click on it and go to assign excitation lambda pole. Now you need to change this resistance to 75 ohms and click next. In the integration line, you need to select new line. Now, a new line you can select. To do this, you need to, whenever the cursor is at the midpoint, you will get a triangle. You need to click on it, and then you need to drag it to up to the upper midpoint, and then you need to click next. You need to select do not normalize and click finish. Now the radiation is excitation is also assigned. But if you want to verify whether the excitation is assigned or not, you need to open this excitation and click on it, and it will show you the excitation that is assigned. Good. Now you can execute. Now we need to assign the radiation boundary. To do this, change your axis to XY axis. Go to draw cylinder and draw one cylinder like this. Draw a cylinder like this. Good. Now go to, this is the cylinder, select the cylinder and name it as radiation, and assign its material as air and click OK. Then if you want, you can change the color, like I am changing it to gray color, and add its transparency to 0.8 and click OK and click OK. Now you want to know what are its dimensions. You right click on it. It has 0, sorry, this is not the thing. This is the rating. We need to right click on it. What are its dimensions, you may ask. It is nothing but 0 millimeter, 0 millimeter, minus of lambda divided by 4. And what is its radius? It is nothing but radi underscore co. And what is this? It is height. It's nothing but radi underscore co. And click OK. Then it will be assigned. Now we need to assign a radiation to this radiation boundary. To do that, right click on this radiation and go to assign boundary and click radiation and click leave all things as default and click OK. Then a radiation is assigned to this boundary. Now this completes your setup. This completes your design. Now only thing is left is to assign assign a solution set and analyze this problem. Thank you. Once you are satisfied with your design, now you need to assign a solution setup. To do this, go to analysis, right click on it and add a solution setup. You need to keep the solution frequency as 1 GHz. Setup name, you can give it a setup of 1. You need to increase the maximum number of passes to 20. You see, keep the maximum delta S as 0.02 and click OK. Now open this analysis, go to setup, right click on it and click on add frequency sweep. In this you need to take the sweep type as fast, type of this as linear count and assign it from 0.5 GHz to 2 GHz and keep this count as 101, and you need to say and select this and click display to display at what frequency it is going to plot and click OK. Now the solution setup is also set up. Now you need to click on this to validate your project. If any error is there, it will show here. As all have been over, you get a screen like this and click OK. Then you need to click on design in order to solve this. Let us see. It takes a little bit of time. Yeah. See, it is starting with it. If any problem is there, it will display it here. If no problem is there, you get a normal. You get a message saying it all is normal. Let us wait until the solution setup is over. If you are hearing some noise behind me, please ignore it. I am recording it at the right. So yeah. See, it's almost about to over. Let's see. Yes. Yeah, you get a message saying normal completion of server is over. Now you need to go to graphs. For this, go to results, right click on it and select create model solution data report and click rectangular plot. By default, it will show you the source 1, 1 and your function should be in decibel and click new report. See, you get a thing like this. Now to plot the radiation efficient return loss. To do this, right click on it, right click on the graph, click on add marker and add a marker at wherever the graph is changing. You observe this one is your gain and this one is your return loss, which is minus 0.99. 9.0949. Thank you. Now let us plot the different parameters of this antenna. To do this, go to this radiation, click on this radiation, right click on it, select insert far field, infinite sphere. Now in the infinite sphere, you need to leave it as it is, or else you can change this to 360 degrees and keep the step size as small as possible, like I am taking it as 1 kilo 1 and click OK. Now right click on it, you will see an infinite sphere 1. Right click on it, go to here, click on compute antenna parameters to parameters, and you will get this. These are the different antenna parameters which I have got, and click close. Now let us see the other graphs also. To go now, again go to results, go to create far field report, go to 3D polar plot. In this you need to select gain total none and click new report. If your simulation is correct, it takes a little bit time to generate your report, but do not worry, it is just the normal working of this. It is just normal working, you need not worry. See, if you have done your simulation, you only get a half a sphere. That is correct. Then you have to go to results, create to fast field, radiation pattern, and you need to say radiation efficiency to none and click next. See this again, it is running this, which takes a little bit of time, but not much amount of time. Yes, let's wait until this is over. See, you have got the radiation efficiency this. What is this, you may ask? It is nothing but if you want to rename this, you need to click the graph here and you need to double click on it, or else you can just right click on it and click rename, or press F2 on your keyboard. Yes, press F2 on your keyboard in order to do it. Instead, if you don't have if you have any problem in pressing F2, you can directly go to here. Now yes, you may ask what to rename it as. This is XY plot, that's no problem. Now what, yeah, this is a gain total. Now go to radiation pattern. Yeah, this will be the thing. Now that is over. Now you may ask how you can create the copolarization and cross polarization graphs in electric field and magnetic field. For the electric field, you need to go to this, go to far field report, go to radiation pattern, select gain theta, and select your function. Select your function as decibels. Now to plot the copolarization graph in electric field, you need to click on this edit, remove this and select 90 degrees. Yes, wait a minute. Let me, as I have selected my step size as 1, I am getting these many values. If you select the highest step value, you get the smaller values only. But yeah, and select your 90 degrees and click new report. See, you get a graph like this. This is a radiation electric field copolarization vector. Now you can rename it and write E field copolarization polarization. Okay, now if we go polarization and you can click it. Now to plot the cross polarization, again go to results, create far field, go to radiation pattern, gain theta, decibels, go to families, set the phi value as 0 and click new report. This is a radiation efficiency cross polarization, and I will just say, okay, I will just rename it as E field cross polarization. Okay, now you may ask, now how we plot this in magnetic field? To do this, go to far field again, go to radiation pattern. Now select gain. Instead of gain theta, you need to get gain phi, and again this will be decibels. Go to families. Now in magnetic field, to plot the copolarization, you will select the phi value as 0 and click new report. See, you will get a graph like this. Now if you want to plot it in, if you want to plot the cross polarization also, you need to again select gain phi decibels, go to families, go to this, okay, edit, go remove this, okay, go back, select 90 degrees and click remove report, and you'll get a report like this. I hope you enjoyed my explanation on how you can create a monopole antenna using HFSS software. If you have any suggestion on what other kinds of videos should I make, please comment down below. If you like my explanation, please like the video, share it with your friends, and do subscribe my channel to see more such videos. Thank you. Thanks for watching and have a nice day.